Hello everyone, my name is Rungroj Maipradit, PhD student from Nara Institute of Science and Technology, Japan. Today I would like to present my journal first, when for it, identifying on-hold self-admitted technical debt. So first, what is self-admitted technical debt? Self-admitted technical debt or SATD refer to situations where a software developers know that their current implementation is not optimal and indicate this using the source code comment. Previous study found that SATD is not uncommon in the software project. Up to 31% of the file contain SATD. And also, 20 to 50% of the removable SATD were accidental and are even unintended. So our goal of this research is to support developers in managing the SATD. To understand what kind of SATD could be addressed or managed automatically, first we create a qualitative study on the sample of removal of the SATD. By looking into the dataset and randomly sampling with 95% interval, we saw in 333 sample of the comments. From 333 comments, we asked, does the comment represent the SATD? Among the removal comments, we found that not all of them were SATD. 85% of them were actual technical debt, while 6% of them were incorrectly tagged. And 9% of them were not actually removed, but only edited. Among the SATD comments, we asked what kind of SATD was it? From the SATD comment, we found that the most common kind of the debt are functionally needed at 44% and live furthering needed at 17%. Then we asked, do the removable commit actually fix the SATD? We found that the majority of the commit at 58% does not actually fix the problem. Then we asked among the fixed commit, what kind of fix are applied to address the SATD? From the result, technical debt were either fixed by implementing the new code at 58%, by refactoring the existing code at 15%, by removing the code at 12%, by uncommenting the code that had been previously commented out at 7%, or by removing the workaround at 4%. This is the relationship between the type of SATD and how they are fixed. The frequency is shown based on the type of SATD. From this relationship, we found that many instances where new functionality was needed were addressed by implementation of the said functionality. And the case where refactoring was needed were addressed by the refactoring. In the case of clarification requests, we found that they were resolved by simply deleting the comments. And in all cases, the majority of the comments of all type were removed without fix. We look into the SAD comment which had been fixed and asked whether the fix applied in this commit could be applied to similar contexts in the different projects. So we could envision the tool support to address our comment automatically. The results show that 1/3 of the comment could possibly apply to the different projects. Among these, we identified the two kinds of STD that could possibly be handled automatically. One of them is the comment indicate that the developer is waiting for something. Which leads to final question, does STD comment include the condition? From our study, we found that 10% of STD include the condition. Since no other obvious cause of STD emerged, we seem amenable to automated tool support. We focus on this kind of STD for building the classifier. From the last question, we define a new type of STD called on-hold. On-hold STD is technical debt which contains the condition to indicate that the developer is waiting for the same event or update functionality has been implemented elsewhere. This is an overall process of classifying the on-hold STD comment and detect the specific event that developers are waiting for. To find the best performance, we use STD comments as our input, which gathered by previous research. They collect data from commit removing STD in 15 open source projects. We manually classify STD comment into the on-hold or not, and use it as a ground truth. In this ground truth, we exclude the comments that are not related to SHD or already selected as the sample of the removed comment. The first step is term abstraction. We apply this process because we are more interested in the existing of this type rather than the actual term, which do not appear frequently. In an example, we abstract the word camel 1475 into the abstract product, abstract bug ID. In the second step, in the n-gram feature extraction, we extract n-gram by applying the n-gram IDF. N-gram invert document frequency, or in short, n-gram IDF, is theoretical extension of the IDF for handling multiple terms and phase by bridging the theoretical gap between term weight and multi-word expression extraction. N-gram IDF can detect dominant n-gram and exact key term of any length. In machine learning, two problems were known. The first one is no single machine learning method perform the best on all datasets. And the second one is some machine learning method rely heavily on hyperparameter optimization. Automated machine learning address this problem by running multiple classifiers with different parameters to optimize the performance. Thus, in the classification selection step, we apply auto-scikit-learn and automated machine learning. Then we build a classifier that can identify the on-hold SATD by classifying SATD comment into the on-hold or not. The naive baseline were created using the frequent word that appear in the on-hold SATD. We also run the comparison while using the TF-IDF as feature extraction and using the same setting on the auto-scikit-learn. To measurement the effect of the rebalancing on our classification, we also compare the performance of the n-gram TF-IDF with and without the rebalancing. Our proposed classifier n-gram TF-IDF has the best performance in every evaluation except the precision, which has similar score. And the final step is the condition detection. We ask how well can our classifier automatically identify the specific condition in the on-hold SATD. So during the annotation, we found that the pattern is related to first, waiting for the bug to be fixed. Second, related to waiting for the new version of the library. Third is related to waiting for the past the certain days. This is the example for each type and what it will look like when they were abstract. So our assumption for identifying the condition in the on-hold SATD can detect some parts of the on-hold SATD. Our result for detected the specific condition 90% of the specific condition were correct. 10% of our pattern were false positive. Keywords are using for the reference, but not for the condition. And 43% of the on-hold comment, we were able to identify the specific condition that the developer was waiting for. That's all for my presentation. Thank you for your listening.
Okay, I guess we are live now. I don't see any questions on this chat. I encourage everyone to be bold and post some. Okay, I have some. So uncommenting code is considered a fix. Could you explain how was something fixed by uncommenting code? Was there no new code added, or how was it?
Thank you for your question. So from our qualitative study, from the dataset that provided by model Dados, so in that state, we manually analyzed all of the comments from 333 comments. We found that some of them, like when they were mentioned in their commit that this comment were fixed or this problem was resolved, we found that they didn't add anything new. They just removed the comment part of the code and like they commit that one. So we classify that type of fix as just remove the comment. Uncomment the code.
Okay, and you classified this to be fixed and not to be removed, right?
Yes, to be fixed because they mentioned that in the commit.
Oh, they said something in the commit message that they fixed.
Yes.
Okay. That part I didn't realize that there was like the comic part analysis. Okay, we have a question. Do you think developers should establish practice of having to-do when comments in addition to standard to-do comments to make on-hold SATD more visible?
Thank you for your question. So I think in some case, like to refactoring or remove some problems. I think in that case that maybe they don't need to mention to do and when, but in some case like they rely on the additional condition or additional factors such as when they rely on some bug ID to be solved or fixed. I think when they mention to do and when, it should help in both developers and the tool to detect the condition and help developer to resolve the SATD more faster.
Okay. So can you clarify how you identified SATDs in the code? Was it keyword-based process? If so, what were you looking for?
Thank you for your question. So in our paper, we identify one specific type of an SATD called on-hold SATD. So in this process, we manually classify by the authors of the papers. So in this process, we looking for some specific type of SATD that mention that they're waiting for some things. Our original datasets were already the SATD code that provided by model data. So we're looking for something like they're waiting for some bug to be fixed. They're waiting for some new library version to release, or they're waiting for some data to be passed first. That is what our paper doing.
Okay. And if we go, while we wait for more questions, if we go back to those fixes, so how did you actually determine that something was a fix? So for example, I mean, I actually read your paper. It was very nice work. And then I looked at some of the comments. For example, it says to-do should leverage AOP around when we have support for that in Camel Core. And if I would look at this comment, I wouldn't know how to fix that without knowing the source code. So can you explain how do you know something is fixed or not?
So when we look into the comments, so we look into the two parts. The first part is also what they mentioned in their commit, because sometimes we not quite sure what they actually do on the comments. So first we also look into the commits, and second we look into what they changed between, because we study on the removal of the comments. So we look into the modified part of the code too, did something actually change, or did they mention something in the commit? And so we have 2 persons to do manually analysis. Do qualitative analysis, and when if 2 person is conflict on the label, we ask the third author to resolve this one.
Okay. And you mentioned some kappa numbers there as well in the paper.
Yes.
Yeah. It seems, in some cases it can be difficult to determine. I mean, kappa 0.6 is quite good, but still there are cases when it's difficult. Yeah, and I noticed.
So maybe I actually did more something that may be more clear, is it SHD or not SHD? The kappa might be high, but in some question I think it's about can we apply this fix to the other project? I think the kappa dropped quite a lot compared to the first question. So yes, I think in some question it's quite hard to resolve.
From some comments it's difficult to say is this not, and then you're kind of in the middle. Okay, we have more questions from the audience. So next question, would it be better if docs again includes to do when keyword? If so, how do you success it work with?
What is So sorry, I'm not quite understand the question. Could you clarify this one?
I think this means that you have like the docs you can tag, so not just add to do, but also add to do when if it's on hold.
Oh, I see. So I think also my external research from this paper, we look into like some links in also the code comments. So I think if there are something like to do and when it should be, for example, when the it relate to some bug ID or something like that. If the bug ID is fixed or getting removed, we can build some notification tool or something like that to mention to the developer that okay, this comment can be fixed right now. Could you please come back to check on this one or something like that? That is our idea on this paper.
I think the question relates more to that it could be supported by the tool as well.
I see.
Okay, so next question: are on-hold SATD resolved faster than the non-hold SATD? So was there a difference in the resolution time on the hold one?
So in this, thank you for the question. In this paper, we didn't look into like the different speed in when they remove or not remove. I think that it should be interesting in the future. Like we didn't look into this perspective yet.
Okay. Based on your study result, next question. So based on the study result, is it possible to use the conditions you can identify for monitoring and suggesting the developer when is the moment to remove on-hold SATD from the code? So like a reminder of or something like that for the developers.
On the study result, is it possible to use the condition? Yes, I think it's possible to. Thank you for the question. I think it's possible to build a monitoring tool to suggest the developer to remove the SATD. Like as I mentioned before, like our additional study, like we look into the link in the code comment. I think when we identify the link, we can build a tool to help the developer to mention that okay, this comment can be removed or not. Yeah, but about the Doxygen, I didn't look into that one. I will look into that later.
Yes. So there could be like automated reminders that when some bug is fixed, you can remove the ugly workaround stuff. Yes. Okay, so we have 10 seconds. I thank the audience for the questions and Rungroj for the answers and the discussion.
Thank you very much.